In this lecture, we are going to do the remaining problems associated with lecture 1, 2, and maybe 3. And in this problem, we need to write and run a program that prints the sum, which means addition, difference or subtraction, product or multiplication, quotient, and remainder of the two integers. Initialize the integers with values 60 and 7. So first we need to save this file as a CPP extension so that whatever we are typing on is color coded for easier typing and removing the errors as we go along typing the program or the software for it. So we are going to file and save file as. I'm going to name this file as EE163. .cpp. Extension is important, and since we do not want our compiler to see this thing, the question itself, so I'm going to make double quotes, double forward slashes to comment this thing, or let's try to make this program. So first thing we need to put is include a preprocessor directive. So I'm going to include IO stream, because it contains the definition of cout, cin, and input and output operators. And then I'm going to use using name space standard. That's a statement, so it ends with a semicolon, and then I write integer main void, or just leave empty. I can just write void, or I can just leave it empty. That also means it's void. So it depends when you want to write it or not. Okay, so if I curly brackets has opened, and let's see. So what we need to do is that we need to declare integers. We can just name integers an x and y, or m and n, or something like that. So I'm going to declare an integer m and n, and then I can write m equals to 60, and I can write n equals to 7. So in this line I have declared the integers, and in these two lines I have initialized the integers. I could have easily done it. I mean, let's write it in comment, because instead of writing these 3 lines, I could have written integer m equals to 60, comma n equals to 7 and semicolon. That would have done exactly the same thing with no problem at all. So because I'm not using any reserved keywords for variable names, so there should not be any problem in declaring and initializing these variables. Okay, so next thing is I need to print their output, what their sum is. So if I write cout and the output operator, and I'm going to write the integers are, well, end of statement. I'm going to write m, and then write and n. I'm going to write and l. So what's going to do is it's going to print integers r, and it's going to print the value of m, and then it prints this string literal, and the whole string, it contains 4 characters, and then it prints the value of n, and then it goes to the new line. So then we want to print their sum, and their sum is, and another output operator. I'm going to write m plus n. I mean, this is a mathematical expression. It's going to be evaluated, and it's going to return the value of 67, and that is going to be printed. I forgot to terminate this string. Now it's okay, because that's showing as in color coding. And then I write and l. Okay, then I print another line for their difference, and I'm going to write their difference is end of the string, and I write another mathematical expression m minus n, and I write and l. How do you practice this coding? It's strongly suggested that you type along as I type along. Whenever you are looking at this video, or on your mobile phone or on your computer, open a code blocks window on your computer and type as I'm typing. So once you get a feel of typing, and once you practice that keyboard typing of these code, then the coding becomes really simple and easy because it's really logical. There is no complicated stuff in this coding. Just need to learn the syntax and how it's used, and you just tell the computer what to do and it will just behave as expected. Okay, now we have printed their difference. Then we need to print their product. Okay, and their product is, and just write the M and steric N. We cannot write X for the product. X is a letter. We need to print this special character, which you can type using Shift and 8 or look it up on your keyboard. Then going to the new line and L. Then I need to print the result of their division. So I write C out, and their quotient is, then I use this bracket M divided by N and L. Then I write their remainder, C out, and let's see. Their remainder is end of the string and M, and the remainder operator is percentage operator. If you divide 60 by 7, so the result would be 7 into 8 is 56. The remainder would be 4. So I think 4 should be printed over here. Let's see. And L. And well, that's it. So let's see how this thing works. If you want to make it a little more easy to read, so we can have like this so that it looks rather okay. Let's see how it works. Okay, so the integers are 60 and 7, so it is not printing a space after it, so I need to put a space over here. Now it's saying the integers are 60 and 7, so it's printing the value of M over here, and it's printing the value of N over here, and these are essentially string literals, so you can just put any message over here or anything. Okay, their sum is 60 plus 7 is 67, so this is a mathematical expression evaluated, and the value which is returned is printed or is put to the output stream, so that the C out using this output operator puts out the output over here, 67. Their difference is M minus N, 60 minus 7, 53. Their product is M into N, so 60 into 7, 7 into 0, 0, 7, 6 into 6 is 42, so it's 420, and the quotient is 8. I'm going to revisit this in a moment. Why is it 8? The remainder is 4. It's really simple to understand because I've just explained it. Remainder operator, if I can just write it over here using a pen tool. So let's see, why is it 4? So if I have 60 and I divide it by 7, so 7 into 8 is 56, so the remainder is 4, and this 4 is displayed over here. Quotient is 8. I mean, if I divide 60 by 7, 7 into 8 is 56. Sorry for bad writing. 7 into 8 is 56. The remainder is 4. So what we do is we put a decimal place over here. It becomes 40. Then we do 7 into 5 is 35. Remainder is 5 in this scenario. So that means that if I put another 0 over here because we already put the decimal place over here, then it will be into 7, that will be 49, and it just keeps on going and for forever maybe. So but since we have divided integer with an integer, the result would be an integer. That's why it's displaying 8 over here, and the quotient and the division is. Had it been a floating point number, we are going to visit that in this lecture and the next, then it would have displayed the output with the decimal part as well. And if we want to do it, we can do it in this part as well. So let's see if we can do it over here. Let's say if we want to I mean, the remainder is always an integer because it's only divided it once and sees what the remainder is. Had it been like a 63, remainder would have been 0 because 7 into 9 is 63. Let's try doing it with 63. So coming back to the mouse pointer and removing those, and let's see what we get. Okay, so first we need to close the window because the build and run would be disabled. So let's say had it been 63 and see the result. So the quotient is 9, 7 because it's perfectly divisible. So now 63 divided by 63 divided by 7 is 9, and the remainder is 0 because if you divide 63, and this is a comment actually, if you divide 63 by 7, there is no remainder after the division. So what, let's say, coming back to our original problem, let's say the numbers are 60 and 7, but what we need to do is we want to have the right answer with the decimal part as well. Since both of these things are an integer, the result would be an integer. It will just pick the integer part in this quotient line or quotient statement over here. So what I'm going to do is I'm going to make one of the numbers as float. Let's see. So if I write integer m, and I've initialized m with 60, and I cannot use n without initializing it. So if I write float n, and I initialize n with 7 because it can and cannot contain, it can contain a decimal part, but since there is no decimal part, let's see what the results are. I've just changed the type over here, so that means that all of these expressions, let's first run this thing and see what we are getting. Invalid operands, oh yeah, I mean we cannot do this because we just want to see the quotient part over here. Invalid operands type integer and float to binary operator percentage, which is a remainder operator. Remainder operator expects that we put the integers in here. So how to solve this thing, going to see that in a moment, or maybe in the next lecture. Let's run their quotient and see what we get, because our original target was we wanted to see the whole answer, not just the integer part whenever we are dividing one number with another. Let's see what we get. There we have it, and the integers are 6 and 7. Actually this 7 is no longer an integer, it's declared as float, but because since we have written, you can just write anything over here, doesn't mean anything, just a string literal. Their sum is 67, which is okay. The difference is 53, also okay. The product is 420 as before, but the quotient is 8.57143. Now it's displaying the whole part, the integer part as well as the fractional part. The reason is that m is an integer but n is a floating point number. That means I'm going to discuss the details of floating point number, how they are stored and what their format is in this lecture, maybe in the next lecture. It's a detailed lecture. So but the point is, if one of the operands, because this thing is an operator, a binary operator, it's a division operator or quotient operator, it's operating on two operands m and n. Initially both of them were integers, so the result is also an integer. It just picks the integer part and it was displaying 8. But now one of the operands, one of this, I mean m is an integer, but the other operand n is a floating point number. So that means the whole expression is now upgraded or should we say, typecasted to a floating point number. What happens is when this compiler encounters m, it treats it as an integer, but it's being divided by a floating point number. So what it does is that it converts this m into a floating point number. That would be 60.000, and it still remains 60, and then it divides this floating point number with this floating point number, and it the result would be another floating point number, which we just saw. I mean, let me revisit that, and it displays the whole floating point number with the fractional part as well. Now coming to this thing, I think it probably would work. It says that you cannot use a floating point number with this operator. So what I'm going to do is I'm going to reconvert this thing into integer. So if I write integer, let's see if it works. So what I'm going to do is I'm actually overloading this thing. Let's see if this thing works. Remainder is 4 as before. So what we have done is this m is an integer, because we have declared as an integer. N is a floating point number, but the remainder operator does not take floating point numbers as its operands. So what we did was we converted, or we typecasted this n into integer, so that this whole thing becomes an integer. So the integer, remainder, integer, and the remainder operator is happy, and it says that if you divide 60 by 7, you will get the remainder of 4. So but this topic is related to the next lecture, so that I will explain it in detail, how this typecasting works. But we can use this to convert one type into another type. It's going to be discussed in detail in a future lecture. So I think this solves our problems, that write and run a program that sums the difference, sum difference, product, quotient, and remainder of two integers, initialize the integers with the value 60 and 7. So coming back to our original part, it should have been declared as integer as the requirement was. Okay, so the next problem is write and run a program. Is it the same problem that prints the sum, difference, product, quotient, remainder of the two integers that are input interact? Okay, so what we need to do is we need to take the input from the user using the input operator and the cin string modifier. First we need to once again file and save file as, I'm going to name it as e9.cpp so that I can get color coding in this code blocks, and I comment these lines and write the code as before. So what we need to do is we need to take the input from the user. So the first line is once again the preprocessor directive. We need to include IO stream, and the second line is using name space standard and integer main, and it's actually a void, no arguments for the main function. Okay, so first thing is we need to declare the integers, and then we're going to take the value from the user as input and assign it to the these integers which we are just going to declare right now. So I'm going to write integer m n, and then I'm going to print some message for the user saying that enter two integers, put a space over here, and then maybe not necessary for the new line, it's going to print in the same line, and then we use the object cin and the input operator m, and then another input operator n. I mean, I could have written two lines cin m and then another line cin n. I mean, these two mean exactly the same thing. I mean, this line or these two lines, because I put a semicolon over here, they are essentially two lines over here, they mean exactly the same thing. And if you're not happy with it, I can just write here and here. I'm just commented it because I do not want to run again and again, but just to explain that had I placed these lines over here, the and without the comment part, then these two lines mean exactly the same as this single line. What it's going to do is it's going to display the message or the string literal, and it says enter two integers. So when I press the first integer, when I enter the first integer and press the enter key, the cin3 modifier takes that input from the console and assigns it to m. Then I press another integer, or enter another integer and press the enter key. Cin takes the next input and assigns using the input operator to n. So the console output is this thing is going to the output, see the arrow, and cin with the input operator, whatever is typed at the input is assigned to m, and the next input is assigned to n. We can take multiple inputs like that, and those inputs are separated by the enter key. And the rest of the exercise is really simple. I mean, you need to print the whole thing. So put some cout message. Same thing, the integers which we have just entered are, I think this is the same thing exactly. I'm going to type it m and another and the value of n over here, whatever the user has entered, and l. Okay, and cout their sum is, for some spaces over here, and then I think the same exercise really. So it just, the only difference is m plus n. Only difference is we have taken the input from the user instead of initializing it in the program. So user can enter any numbers he or she wants. Cout their difference is m minus n. Cout their project is end of the string, output operator, brackets, and m into n. Cout their quotient is m divided by n. Once again, it's these are two integers, declared as integers. It will only take the integer part. Even if it divides it, it will just take the integer part of the result. So even if the user enters the, I'm going to see what I'm going to run this program again and again and see what happens. Okay, so I think we forgot to terminate the string. Now it's okay, and I'm going to write and l. Their remainder is end of the string and m percentage n, and that's it. I think should not be any. Let's check the if you want to make it look good, so you can just input some space bars over here so they're aligned properly. I think let's run this program again because do some antivirus. Okay, Enter two integers. First number is, let's put with the same values so that we can compare the results. 60 and 7. Enter. The integers are 60 and 7. Their sum is 67. Their difference is 53. Their product is 420. Quotient is 8 and remainder is 4. So let's run this, because I have already built this program. So whenever I just do build and run, it develops another executable file, and my antivirus software kicks in and places the whole application in a sandbox, and when it detects nothing dangerous, it just escapes that thing. So I've built this program already, so I'm going to just run this program again and again for a different, do not need to rebuild because I haven't changed the code yet. Okay, enter two integers. Let's put 10. Enter 20, and integers are 10 and 20. Their sum is 30. Difference is 10 minus 20 is minus 10. The product is 200. The quotient is, if you divide 10 divided by 20, the result would be 0.5. But since both of these numbers are let's pick a tool over here. So let's write it over here. If I write 10 divided by 20, so if I put 10 over here, 20 over here, I would put 0 point here, it will become 100, and 20 into 5 is 100, and it will be after division, this part, it will be completely divided. But the integer part of this thing is 0, and this 0 is displayed here. Remainder is 10. Reason is simple, that if I divide 10 by 20, this thing, even if there is essentially no number greater than 0 which we multiplied by 20 and get something over here which is less than or equal to 10. So this thing is not divisible with the whole number part. That's why the remainder is let's pick another one. That's why the remainder is 10 over here. Let's run this program again. Actually, it's really simple to run this program again and again if we are using some kind of an infinite loop. Going to discuss those loops, but since we haven't discussed those loops yet, so what we're going to do is we are going to run this program again and again. So let's run this thing again. So if I write 44 spacebar 66, enter. I could have also entered using a spacebar and not with enter key, because whenever the cin object stream input stream modifier is kind of a smart object, it takes the input, and when it sees that, it's expecting an integer, and once we have pressed 44 and then if I pressed a spacebar, it senses that the integer input has now been terminated, and then it moves to the next input operator. And when I press 44 spacebar 66, that means that 44 after that spacebar, that means that this integer has now been completed. It assigns this 44 part to this m, and then it once it gets the next integer, it assigns this integer to this n. The integers are 44 and 66. Their sum is, well, as expected. Difference is 44 minus 60 minus 22. The product is this thing. Quotient is 0. If I divide 44 with 66, it will get a fractional value, but it only gets the integer part of the fractional value, that would be 0. 44 is not divisible by 66. That means the remainder will remain 44, because there is no number greater than 0 which you can multiply with 66 and get a number less than 44 or equal to 44. Okay, so let's try it again, and let's see what if we put something like 23.45. It throws up an error. Okay, EE163 has stopped working, and the reason, can anyone explain what actually happened? Was close the program, and where was the error? Let's see. Once again, I tried to enter a floating point number as an integer, and once it encounters, it's quite complicated what actually happened over here, but let's try to explain what happens. Because we haven't discussed the ASCII code yet. So cout says enter two integers. I try to enter 23.45 and then I press enter. And what it did was that it took the 23 as the first part, and it says that once it encounters a character which is not part of a number, it just assigns that whatever input of the number is to m, and then it takes 45. But it's not seeing, I mean, this decimal part has some kind of an ASCII code starting with maybe 0 or something, so not so sure about it. It just assigns a 0 to n. Okay, the sum is 23, the difference is 23, product is 0, but the quotient is 23 divided by 0 is infinity. That's why it throws up the exception, or it says process returned this thing and it did not run well. It will be much more clear once we have done the ASCII code, and we'll see that what actually entered this input stream when we press this part over here. So let's try it one more time. Let's see what we get. Let's say we press A, enter. Okay, let's run it again. I'm not so sure whether it's taking these characters in integers or what, but once we 0 and 16, but why it took 16? It should have taken 97 probably, but we are not typecasting these letters as integers, so we can just leave it with that. But if you have these numbers, I mean, the product is 0, quotient is 0 divided by 16 is okay, and 0 divided by 16 is not divisible by this thing, the remainder will remain. Oh no, it is divisible. 0 divided by 16 is divisible, so you will get the remainder of 0. I'm not so sure why it got 16 over here, because I haven't typecasted the character input as the integer inputs. One more thing to remember is, if you are not so sure whether the user will remain the user will type as you have wanted, because you are requiring integers and the user is typing a floating point number, or user is typing a letters or some weird looking stuff, so you need to do some error handling. If the user has, and first we are going to develop that as the course moves along. What we need to do is we need to develop some kind of error handling, so that we should detect whether the inputs are correct or in the correct format. Whether the inputs are, if you are expecting integer, the input should be integer. If you are expecting a floating point number, the input should be like that. If you are expecting character, the input should be like that. We should have some kind of an error handling capability built in our code. We are going to develop that, and we are going to check the inputs first, whether the inputs are correct or not, and then we are going to apply the perform the required mathematical operations or whatever operations our code is designed to do. So first we need to check whether the inputs are correct or not. We're going to develop that in a future program, but here we're just going to hope that the user is going to enter integers and not some other stuff which is unexpected. Okay, so coming to the last problem, write a test program that shows how your system handles uninitialized variables. So if we have uninitialized variables, the system might, first we need to save this thing, save file as, we're going to write it as e10.cpp, and it's a comment line, so that write it how your system, I mean each system might behave differently. Okay, so first, I mean the reason why I mean, if you are working with some Android system, you can just download a C++ compiler over there. It might run differently. How do you type on that mobile phone? Depends if you have some kind of a Bluetooth keyboard, or you can have a virtual desktop experience on your computer, something like that. Or let's say you are typing on a Windows laptop, it might throw up a different behavior. If you're typing it on a Linux desktop or Linux operating system, it might throw up a different behavior. Same is with the iMac or the Apple computers. So let's see what happens when you have uninitialized variables. We would be declaring the variables, but on intention we would not be initializing or assigning them values. So what is going to happen is the variables which we declare are going to be some memory space is going to be assigned, and it will be represented by the variable name, the symbol, let's say variable ABC, something like that. But that would be occupying a memory space which would have been occupied by some previous program. It might have written some garbage value over there, which is not actually useful for us, because the computer memory is never actually empty. It has something written by some previous programs. It is always overwritten. So whenever the operating system assigns a memory space to our program, our executable file, in this case e10.exe, that memory space would need to be overwritten by our own values. If we assign a memory space to some variables and then use them, they might throw up some weird looking stuff, weird looking numbers or letters or hexadecimal numbers. Essentially all of them are ones and zeros actually, but those numbers are not valid or legitimate numbers. Those values would be written by some previous program which was occupying the very same memory space which this application e10.exe is going to occupy. Let's see. So the first thing is include iostream iostream angular brackets, and I'm going to write using namespace standard integer main void and curly brackets, and the last line is, I think I did not write anything last line, return 0. I mean, it's a good practice to write this thing. I did not write it. The compiler is expecting it, but if it's not, so it did return 0 if the program ended successfully. Let's see. So the first variable is bool b. It's a special type of integer. Either it can contain true value or false value. True represents 1 and false represents 0. In some programs, any value greater than 0 is treated as true, even if it's 5. So I did not initialize it, I just declared it. So I'm going to write cout and see what the value here is. B equals to, I mean, just a string literal output operator, b and an l, whatever the value of b would be carrying. I did not initialize it. It might be occupying some place in the memory. It might contain 0 or 1, I don't know. Let's see, or maybe true or false. So an l, then character c. Once again, these are just declared, they are not initialized. Once again, this is not initialized, this is just declared. We are just allocating a memory to this variable. I'm going to write cout c is or equals to, you can just put anything here. You don't need to write, I mean, whatever you just put here, I can just write is over here or anything you want to. Okay, so it's just a string literal, and c is, and I'm going to write c, the value of c. Let's see if it works. I'm going to write an l, then integer m. Once again, not initialized. I mean, by initialized I mean I should have written m equals to some value, let's say 20 or 25 or any number, but I did not do that. I'm going to see what the output is, or I mean, obviously all of these things are going to throw some garbage values. So let's see, cout, and going to write m equals to, and m and l, and integer, let's try with float n, and see out n equals to let's try long integer. If I did not write anything, just write long O, okay, and write C out. I'm going to explain what long is. It's actually it occupies twice as much space as a normal integer, and let's see what the output is. O equals to and after that I think it's I can just put float is done. No, double precision float, which is double p, for example, and see out p equals to p and l. Let's see. I mean, all of these things are not initialized. This is not initialized, this is not initialized, and let's see if I get some no errors. So look at the values. Bool b, it says 0. We did not initialize to false. Character c, and c contains nothing, which is actually displayable. It might be some value. Let's see what that value is. If I can just because it's treating it as an integer, maybe m equals to 16. I did not initialize to 16. N equals to 0. Once again, did not initialize to any value. O is some weird looking number, that's what it's occupying, and p is some extremely small number, e to the power minus 322. Once again, these are garbage values. I mean, these values were written by some previous program occupying the very same memory space, so it's important. Let's see if I run this program again and I get the same values. Not so sure about it. I think value of O has changed. Has it? 8806224. Let's run this thing again. Now I mean, every time we are running this program, it's being allocated a slightly different memory space by the compiler. Sorry, not by the compiler, by the operating system. When we build and run this program, an executable file in this path is generated, and this executable file is run as an application, and this executable file is provided a memory space, and this memory space is allocated by the operating system. In my case, I'm running Windows, and this Windows operating system is allocating a memory space to my executable file, which I've just developed and compiled actually. So it's occupying maybe a little different memory space, and since we are declaring the variables, we are assigning some memories to or memory address or memory space to these variables, and they might be occupying a different memory block each time, and they are picking up garbage values. So it's very important, whenever we declare the variables, we must initialize them and do not use uninitialized variables, because in that scenario our application would behave erratically. It might throw some garbage values, because if the input is garbage, the output is obviously garbage, so we need to avoid that. So whenever we are declaring some variables, we must initialize them there and then, or we have to be really careful that if some variable remains uninitialized, it will pick some value which we do not expect it to be, because it can contain any value, and it will throw up errors in our program execution.